Hello, think all are doing well. Okay. The last session we have discussed assembly language, instruction sets, as well as the bit manipulations and the CPU architecture, everything, right? Today I'm going to start a new session related to the DBMS, database management systems. Okay. As per your syllabus, second, I'm going to share your screen. This session I'm going to cover the topics. It's in our syllabus, chapter number 8. So, second syllabus copy. Yeah. So, it is a Cambridge series. We have the chapter number 8. It is related to the database. So, we have database concepts, database management system, data dictionary, and all, and DDL and DML that they can discuss today. As of today, I'm going to discuss the 8.1. One second. Where is your syllabus? So this one and all we have finished. These things I have already finished in the your classes. So this is the topic I'm going to cover. File-based approach, and now we have a relation-based approach. And what are the terminologies, entity table that I'm going to discuss, and ER diagram, and first 1NF, 2NF, and 3NF. This topic I'm going to cover today. Okay, now to share the screen. So this is the chapter databases. So for in that, the first one is file based versus relational based. The file based approach, it was using the before, so many years before they are using the file based, everything in the form of text format, in the form of .txt, .csv. Okay, all the documents. For example, in the classroom, the teacher was writing the uh, that your attendance in the form of sheets, right? Like that, it is in the form of file. It is a older approach. So, what are the disadvantage or limitation? There is a chance of data redundancy. What is the meaning of redundancy? Redundancy is nothing but duplicate files, or else data is going to repeating data, and data inconsistency. You can't in the file based, there is a chance of data inconsistency and poor security. Anybody can use or to control the access. And no, there is no, we can't relate it between one data to another data. One table, there is not, there is no meaning of table. However, there is no chance of the relationship, and there are very difficult to update. And update means you want to update means you have to cross check each and everything. And data dependency, everything is dependent on the file structures. So these are all the limitation if examination point of view. What are the disadvantage or limitations of file based? Okay, now the second one is relational database. It is so all the data are storing in the form of table, rows and columns. So that is the new approach, RDBMS, Relational Database Management System. Relational means it is in the form of rows and columns. You can relate one column to the other column, one row to the other row by using the different types of keys. That is known as Relational Database, RDBMS, Relational Database. And what are the advantage? So what are the disadvantage of file-based? The disadvantages: you can reduce the redundancy and improved consistency, easier update, better security, data relationship via keys. We can discuss one by one. So there are different terminologies in the DBMS. So what is the first terminology as given? The entity. Entity means it is a real world object. Example, I'm a teacher. I can take that is a teacher. That is a noun. We are using the noun, right? That is the teacher, a student, a real world object which is data stored. It is known as entity. Okay, now next one is table. Table is a collection of related data about one entity and organized in a rows and columns. Here, I taken student ID, name, and age, right? These are all the entities. Okay, organized in the form of rows and columns. Here, there will be rows and there will be a form of columns. Okay, that is known as table. Next, it is a record. Record means what are the values in the row wise. A record is also known as tuple. Is a single row in a table representing one instance of an entity. I can take here 101, Ali and 15. I taken. It is only one row. Row wise is known as record, and column wise is known as field. Field is also known as attribute. Record is known as tuple, and field is known as attribute. It is a single data stored in table in the form of columns. Here, student, and student ID, name, and age. It in the form of columns, that is known as field. In the form of rows, it is known as record. And that you should know. Record is known as row, and field is known as column. Don't confuse. Okay. Now we can go to the keys. This is very, very important as your point of your board exam, or else you want to learn the database management system. The keys are very, very important. Not your door key. Okay. The table. What I discussed. What is the meaning of table? It's a form of rows and columns. Okay. First, I'm going to primary key. A candidate key that is officially selected by the database designer to uniquely identify the tuples in a table. Uniquely identify. Uniquely keyword. I can highlight. It is going to. It is a where it is located. Primary always it is located in the first column, and it is a uniquely identifier. Okay, if it is a student may be a different names, right? The student may be same name, so different student of same name, same age, but student having the different or unique roll number, right? That is known as primary key. It cannot contain an null values. It should be one and only one, and it should not more than one primary key in a table. It should be one, and it should not be a null. Okay, next, candidate key. A minimum set of attributes that uniquely identify each record in a table. As per like a primary key only, you have to check what are the different keys that is uniquely identified in a table. That is known as candidate key. A table can have multiple candidate key, all of which must be unique. It should be unique and non-null. Primary key also candidate key only because that is also unique identifier. Next is secondary key. Any candidate key that is not chosen as the primary key. This is not as a primary key, it is known as secondary key. They are used for identification, but not a primary find identifier. Okay. Next is foreign key. Foreign key, a field in one table that identify a row in another table. It is going to connect the table with the other table. It is enforce the referential integrity and creating a relationship between the two tables. That is known as foreign key. It is a one what is that primary key connects to other table primary key. If I'm going to tell in the theory, you can't understand. Now I can go to the 1 second. So can first, as a given the some entities, student ID, roll number, first name, last name, and it's a table. Okay. Here, as I said, primary key is uniquely identifier. It is always located in the first column. And what are the keys here? So what are the entities having unique identifier? You can check. Student ID should not be same, right? It should be unique. Roll number should not be same. First name and last name may be same. Suprith DA. Suprith DA should be. It should. The chance of that is why it is known as candidate key. And email it should not be same. So that is why it is known as candidate key. You see that primary key also considered candidate key. More than one value. Okay. Now alternative keys. Except primary key, the alternative key can you see here? Not first name or last name. So roll number and email. Again, is taking roll number. It is also like a candidate key, except the primary key. Remaining all are alternative key. It is also known as secondary key. The textbook has given secondary key. It is also known as second key. Next, foreign key. Now Yes, there are two tables, student details and student marks. And this is the primary key here, and name and course, and it is a ID and marks, the entities. So, okay, now this ID is going to connected with the student details ID connected with the student marks ID. Here, ID is acting as a foreign key that is going to connect between table to table, and it is a primary key, right? It is going to do the relationship, and it is going to what is that referential integrity that we can discuss in the later. So what are the four types? Primary key, candidate key, secondary key, any candidate key that is not chosen as the primary key, and the remaining other. Okay, foreign key, it is going to connect. Okay, now primary key, it's a row identification, one per the table, right? Candidate key, potential unique ID, like unique ID only, but more than one table. Secondary key, zero or more per table. That is okay. If it is not there, that is also no problem. Foreign key, it is going to linking the table, zero or one more table. So these are all the four types. And your textbook is given primary key, candidate key, secondary key, and foreign key. Okay, now I combined all the things and you can check. So employee ID here, primary key. Employee name may be same. Employee license, it should not be same. Employee passport should not be same. So that is why it is known as candidate key. And the remaining key, except primary key, what are the keys here? Employee license, that is alternate key, right? That is secondary key. And DID, that is the what is that this table, it is going to connect with this table. Here it is not going directly connected to the primary key employee ID. Here it should not be same. It's not a rule. Here which entity is going to connect here? DID and DID, that is act as a foreign key. And primary key and candidate key and alternative key is known as super key. That is not the near syllabus. You must know the candidate key, primary key, alternate key or secondary key and foreign. Now I'm going to do the it is comes under the foreign key. If you want to connect one table to another table, what are the charts? ER diagram. ER is nothing but entity relationship diagram, is a visual and conceptual model representing the logical structure of a database and a mapping out of entity, their attributes and the relationship. So what is the meaning of attributes? We have discussed the meaning of attributes here, right? Attribute is nothing but it's a field. It's in the form of columns. Okay. Now there are different types. One to one. One is connected to C. Two is connected to. This is one to one. Many to one. Many to one means one and two is connected to only one. This is one to one. That is not a problem. One and two is connected to B, right? That is a many to one, and one to many. See, two is connected to A and two is connected to B. Right? That is one to many. Many to many means one is connected to BA, two is connected to AB, and A is connected by. That is the different types of. Okay, now while writing in the ER diagram, you're not supposed to use this symbol. You can use one to one means single line. One to many means this line followed by the this is the many symbol and this is the one symbol. Many to many means you can use this one and ends with this one. And many to one means start by it is up vice versa of this one. One to many. Ulta means many to one means you can change the symbol, and many to many means start from many, and you can write on another one many here. Where is that I can write? That you can write. Okay, these are all the four type of relationship: one to many, many to one, many to many. Okay, now the concept of normalization. This is very important for your board exam. You must know the topic of normalization. So what is the meaning of normalization? As I said, there is a redundancy if the files are repeating. So our task is to reduce the redundancy. In the relational database, what is the advantage you are written? It reduces the redundancy. How we can reduce the redundancy? By the topic of the normalization. Okay, now database normalization is the process of structuring a relational database to reduce the redundancy and improve the data integrity. It reduces the redundancy and it is an integrated data through a set of rules called as normal forms. Okay, now what is the first one? Normal form is first normal form. First normal form is the initial stage of the database normalization, and it ensure that each column in the table contains only atomic and indivisible value, and each row is identifiable. Okay. So what are key requirement? All column contains the atomic value, no list set or composite. Each row is unique. No repeating row. That is the main thing. Okay. Now 1NF means it should have different tables, different columns. See, a customer ID entities, customer name and purchase. 101, John having the purchase product laptop and mouse has the two values here. What in 1NF there? It should be only one value for the each row. One column. Tablet, it is okay. Keyboard, monitor, and pen. How we can convert it into one normal form? See, now I can change to 101. John Doe, and what is the purchase product? Laptop. Again, 101, John Doe, mouse. 102, John Smith, tablet. 103, Alice Brown, keyboard. Next, monitor and pen. Okay, what it is saying, 1NF is saying each column should be only one value. Noted, it is the 1NF. It is a simple one and it is an initial stage. So, okay, now we can go to second NF. Or 2NF. What 2NF says? A table, how we can convert 1NF to 2NF? A table is in 2NF if it is 1F. What is the first condition? It should be 1NF. All the values should contain the single values. Only columns have only one values. And every non-prime attribute, that is non-primary key attribute, non-primary key fully functionally dependent on the primary key. It is dependent on the primary key. The address partial dependent where non-key only the okay. Now if you know, I will tell. So okay, this is the 1NF table he has given. It is in the form of 1NF order ID, all the values, and that is in the form of 1NF. Okay, now normalization to 2NF, separate the customer element on its own table. Okay, now order ID, customer name and product, I can divide into the partial. It is dependent on the primary key. Okay, now order ID I can write and customer ID I can write and the product amount right here. Okay, now I can customer ID or another one table I can perform customer ID as well as customer name. What it is saying? So every non-prime attribute is fully dependent on the entire primary key. This is known as partial dependency, where non-key attribute depends only on the part of the composite key. That's what I'm going to. We can divide order ID and customer ID and product. Again, next customer ID as well as customer. That is also simple. It should be 1NF, and you can divide on the table. That's it. That is known as normal forms. Okay, next is third normal form. A table in 3NF, it should be 2NF, and all the attributes are functionally dependent only on the primary key. There are no transitive dependency. That is non-key attribute dependent on other non-key attribute. No, it should be dependent on only the primary key. Okay, now, so here example, yes, it is in the form of, yes, given in the form of what is that? Order ID, customer ID, product, and supplier is given. Now, issue supplier dependent on the where is supplier? Supplier is dependent on the product, right? Now, HP is dependent on the product. Logitech not directly on the primary key. Here, supplier, this table is dependent on the product, not on the directly on the. There is no supplier ID here, and there is no product ID here, right? So we can create another tables. Okay, can I write customer ID? Sorry, order ID, customer ID, and directly I can write product ID here. Okay, now next product ID. Next, I can handle it into product ID. Next, supply product name. This one, and next is supplier ID. Next, I can create another one table, supplier ID and supplier. See, so the here primary key is the order ID. Now I'm going to divide it into the customer order table, product table, and supplier table. So what is that? Order table, and this is the product table, and next is the supplier table based on the keys. Order ID, customer ID, and product ID. Now product ID it will be the foreign key, right? Product ID and foreign product ID and product name. And again, supplier ID is the foreign key here. It is going to these tables. So remove the transitive dependency and reduce the duplication, improves the data integrity. Okay, now how we can convert in the visual form? Here, order ID, customer amount, and 2NF, customer ID, customer name, and order ID, customer, and I have removed the second. We have two table, customer name and customer order ID, customer amount. We have the order, customer, and amount, city and name, order ID that you can convert, and next customer ID. Oh, this is not required. Okay, now we can go through this one example. You will understand. So what is the 1NF 2NF shares? Now this is the summary. 1NF data is stored in the tabular form and it contains only one value. 2NF it should meet the 1NF, no partial dependency, and it is also it should be 2NF, no transitive dependency, no partial dependency, no transitive. Each column depends only on the primary key. Data split into smaller tables, right? So this is the way we can reduce the data redundancy or repeated files. So these are the topics in the 8.1 database. Is that starting from file based approach and relational based approach. Next we have the terms. What are the terms related to the terminologies? Entity, table, record, and attributes, and different types of keys, and different types of relationships, and normalization, 1NF, 2NF, and 3NF. So these are the topic I have covered today. And remaining topic, so database concepts. Database concept, DBMS concept, data modeling, data integrity, data management, data security, all these things, and DDL. We have a data definition language and DML, data manipulation language. We have different types of writing the queries related to the SQL query, structured query language by using the DML and DDL that I can explain the next class. And this chapter is going to almost cover the 13 marks, 13 to 15 marks. Okay, and it is a very, very important chapter for your board exam. You go through it, and I think it will be useful for your exam. You go through it and you'll get so many resources. You can go to it. If you have any doubts, you can send me the email, or else you can share your feedback in the comment. Thank you. Have a good day.